Hi, good day. My name is Encik and I'm going to present the additional theory and objective. So we have learned that second law of thermodynamics states that energy has quality, quantity, and the actual process occur in the direction of decreasing the quality of energy. Besides, it is also stated that heat flows naturally from the hot object to the cold object, but heat pump is one of the examples that transfer heat in a direction that is opposite of the spontaneous flow, which is from low temperature to high temperature region. It is used to maintain the temperature of a specific space higher than the surrounding by consuming energy. There are many applications for the heat pump, which are heating, refrigeration, and air conditioning. The coefficient of performance is an expression of the efficiency of a heat pump, and the desired output is divided by the required input. So there are three objectives for this lab report, which are to collect the temperature, flow rate, and power data from the heat pump, to measure the power input, heat output, and coefficient of performance of the heat pump system. And the last one is to produce the performance of heat pump over a range of source and delivery temperature. That's all from me. Thank you.
Assalamualaikum and hi, my name is Hanis Husin. My matric number is AA200268. I will present about the apparatus used and also a procedure for conducting heat pump experiments. The apparatus used in this experiment is only salted mechanical heat pump model HE165. First of all, we need to see all instruments are in perfect condition and verify that the units are correct in the system. Next, open the water supply and set the cooling water flow rate to 10% after checking that both the water source and the drain are connected. Make sure the condensate collector's drain hose is attached. Connect the power source and turn on the main power before turning on the control panel's main phase. After that, switch on the compressor for the refrigerant. As soon as the temperature and pressure are stable, the device is ready to be tested. Next, the cooling water flow rate adjusted to 40%. Next, run the system for 15 minutes. Next, all the necessary readings are recorded into the experimental datasheet. The experiment is repeated with a lower water flow rate, resulting in a 3 degrees Celsius rise in the cooling water exit temperature. Next, this procedure are repeated until the compressor supply pressure reaches roughly 40 bars. Next, the experiment can be carried out again at the different temperature. After completing the experiment, switch off the compressor, fan, followed by the main switch and power supply. Then close the water supply and ensure that water is not left running.
Hello, my name is Tang. I will continue discuss about the observation of the experiment. Before the experiment is started, make sure the water supply is open. In the test 1, the cooling water flow rate is set at 40%. After 15 minutes, the power input of the heat pump was recorded at 335 watt in order to absorb 4088.99 watt heat from the surroundings. The coefficient of performance of the heat pump that we have been calculated was 12.21. For test 2, the same step as in the test 1 was repeated with reducing water flow rate, so that the cooling water outlet temperature increased by about 3 degrees Celsius. After 15 minutes, the power input of the heat pump was recorded at 362 watt in order to absorb 3110.97 watt heat from the surroundings. The coefficient of performance of the heat pump that we have been calculated was 8.59. For the test 3, the water flow rate is continued to reduce until the compressor delivery pressure reached around 40 bar. After 15 minutes, the power input of the heat pump was recorded as 412 watt in order to absorb 3725.77 watt heat from the surroundings. The coefficient of performance of the heat pump that we have been calculated was 9.04.
Assalamualaikum and hi, my name is Julita and my matric number is AA200719. The conclusion obtained within the experiment of a heat pump is a mechanical device that transfers heat from one environmental compartment to another, usually along a temperature gradient of such chilly to hot. An energy input such as mechanical, electrical, or thermal energy is necessary to run a heat pump system. Heat pumps are useful for extracting heat from low temperature sources such as the air, surface waters, or the earth. The heat pump was pumping cold air throughout the heating process, which was a problem also during this experiment. The theories as to why this problem exists are due to the air filter being unclean and also the heat pump had a low refrigerant charge. The solution that has been thought to be suitable for the problem is to check the heat pump, and if you are not sure, have a professional inspect it to see if the level are too low or if it needs to be recharged. That is all from us. Thank you for listening.